This video was made for the course Robotics Project Work in Tampere University. Our topic was to develop a human drone swarm interaction framework for persistent monitoring of a large area. The persistent monitoring uses an ergodic controller with a control barrier function as the low-level control to operate a swarm of crazy flight drones. Here we can see the empirical distribution of the drone trajectories trying to recreate the original probability density function. An ergodic controller aims to calculate the drone's control inputs in a way that minimizes the total ergodic metric. Basically, the drones aim to collectively spend an equal amount of time in all grid points. This causes the swarm to explore the search space, which will get fully covered in time. Grid points marked as points of interest are weighed heavier and thus need more coverage time from the drones to minimize the metric. The drones will focus on them and try to avoid already covered parts of the search space, which have less weight. Through the UI, the user can input target clusters, which are transformed into probability density functions and mark points of interest. The target point mode can be entered from the menu with shortcut P. Target points are entered by clicking in the grid window. To finish a cluster, press shortcut F. New clusters are visualized in RViz by running the code. The height and color saturation of a cluster point is based on its PDF value. RViz is also used to visualize and monitor drone trajectories. RViz uses data from the Viking cameras positioned around the test area to determine a drone's location. As the drones move, the grid points they visit turn green. This tells the user how much of the search space has been covered. The drones use QP-based obstacle avoidance to avoid crashing into each other. The drone's safety radiuses are said to be notably larger than the drones themselves to avoid crashes caused by delayed input. The area borders are also set as obstacles to prevent the drones from escaping. If a drone falls, it is marked as inactive. This way, the other drones don't see it as an obstacle and can cover the area where it fell. As seen in the video, the drone swarm successfully monitors the points of interest. If given enough time, the swarm will eventually cover the whole search space and minimize the ergodic metric. Thank you for listening.